Hello there! Welcome to Merritt Education Center, and this is Science with Master Rick. In today's lesson, we will be talking about how chemical equations describe chemical reactions, the process by which one form of matter, the reactants, turn into another form of matter, the products. A chemical reaction is a change of a substance into a new one that has a different chemical identity. It rearranges the constituent atoms of the reactants to create different substances as products. It is usually accompanied by easily observed physical effects such as the emission of heat and light, the formation of precipitate, the evolution of gas, or a color change. A chemical reaction is typically represented by a chemical equation, which represents the change from reactants to products. The left-hand side of the equation represents the reactants, while the right-hand side represents the products. A typical chemical reaction is written with stoichiometric coefficients, which show the relative amounts of products and reactants involved in the equation. Now, each compound is followed by a parenthetical note of the compound state, such as L for liquid, S for solid, G for gas. The symbol AQ is also commonly used in order to represent an aqueous solution in which compounds are dissolved in water. Now, the ancient Greeks first proposed the idea that the total amount of matter in the universe is constant. However, Antoine Lavoisier described the law of conservation of mass, or the principle of mass-matter conservation, as a fundamental principle of physics in 1789. This law states that despite chemical reactions or physical transformations, mass is conserved. That is, it cannot be created nor destroyed within an isolated system. In other words, in a chemical reaction, the mass of the products will always be equal to the mass of the reactants. To write an accurate chemical equation, two things must occur. Number one, each product and reactant must be written using its chemical formula. Number two, the number of atoms of each element must be equal on both sides of the equation. Coefficients are used in front of the chemical formulas in order to help balance the number of atoms. Let's have an example. Hydrogen and nitrogen react together in order to produce ammonia gas. Write the chemical equation of this reaction. Step 1. Write each product and reactant using its chemical formula. Example, hydrogen is H2, will react with nitrogen, which is N2, to produce ammonia, which is NH3. Step 2. Ensure the number of atoms of each element are equal on both sides of the equation. Now, in order to balance the equation, coefficients must be used. Since these are only two nitrogen atoms present in the left-hand side of the equation, a coefficient of 2 must be added to NH3. There are 6 types of chemical reactions. The most common types of chemical reactions are synthesis, decomposition, single displacement, double displacement, combustion, and acid-base. Now let's discuss the first one, synthesis reaction. A synthesis reaction is one in which 2 or more substances are combined to form a more complex one. The chemical equation for a general form of synthesis reaction is as follows. A plus B will yield AB. One example of a synthesis reaction is the combination of iron, Fe, and sulfur, S, to form iron sulfide. Now let's take a look at the equation. On the left-hand side, we have the reactants. We have iron, which is Fe, right, denoted in its state, which is solid, S. Then you add plus sulfur, all right, S, and denoted also by its state, which is solid. It will give you a product of iron sulfide, which is FeS. Now the product is still in the form of a solid. The next chemical reaction in our list is decomposition. A decomposition reaction works quite the opposite of synthesis reaction. It is a reaction where a more complex substance breaks apart into simpler ones. A general form of a decomposition reaction can be written as AB will yield A plus B. An example of a decomposition reaction is the electrolysis of water to form two gases, hydrogen and oxygen. The third type of reaction is also known as the single replacement reaction. The single displacement reaction is when a pure element switches places with another element in a compound. It is in the general form of A plus BC will yield AC plus B. Now, many metals can react with a strong acid. For example, magnesium reacts with hydrochloric acid to form hydrogen gas and magnesium chloride. In this reaction, magnesium switches places with the hydrogen in the hydrochloric acid. So we can balance the equation. So we will come up with 2 atoms of hydrogen, 1 atom of magnesium, and 2 atoms of chlorine. Another type of chemical reaction is the double displacement reaction, in which the cations of the 2 reactants switch places to form 2 completely different products. A general form of this reaction is AB plus CD will yield AD plus CB. Example is the reaction of lead nitrate to potassium iodide to form lead iodide and potassium nitrate. Now let's take a look at the equation. We have PbNO3, which is our lead nitrate. To react with potassium iodide, it will yield, again, two products. One would be lead iodide, and the other one, potassium nitrate. Now we have to put a coefficient of 2 on the left-hand side of our equation on the potassium iodide reactant to balance the number of atoms for our products. Now on the right-hand side of the equation for the reactants, we also have to put a coefficient of 2 on the potassium nitrate side of our products. A combustion reaction is an exothermic redox chemical reaction where a fuel reacts with oxygen to produce gaseous products. A complete combustion reaction occurs when excess oxygen is present and yields primarily common oxides such as carbon dioxide and sulfur dioxide. A complete combustion of a hydrocarbon can be expressed in the form of CXHY plus O2 to give or to yield 2 products of CO2 and H2O. Naphthalene is an example of a hydrocarbon, and its complete combustion also generates carbon dioxide, water, and heat. Now let's take a look at the equation. On the left-hand side, we have the reactants. We have naphthalene, which is expressed in its chemical formula, which is C10H8, plus oxygen, which is expressed in its chemical formula O2, to yield two products. One would be CO2 and H2O plus heat. Now, the acid-base reaction is a reaction between an acid and a base, and water is one of the products. It is a special type of double displacement reaction. A and B switch places. And these chemical reaction examples are written as HA plus BOH will yield BA plus H2O. A simple example of an acid-base reaction is when an antacid, calcium hydroxide, neutralizes stomach acid, hydrochloric acid. Now let's take a look at the equation. We have calcium hydroxide to react with hydrochloric acid will yield two products, calcium chloride and water. All chemical processes are accompanied by energy changes. When a reaction proceeds, it either releases energy to or absorbs energy from its surrounding. Now, these two types of reactions are classified as exothermic or endothermic, respectively. What is the difference between exothermic and endothermic reaction? Exothermic reactions are reactions or processes that release energy, usually in the form of heat or light. Endothermic reactions, on the other hand, are reactions that require external energy, usually in the form of heat, for the reaction to proceed. Now, since endothermic reactions draw heat from their surroundings, they tend to cause their environments to cool down. And that ends our lesson on chemical reactions and balancing chemical equations. I hope that you learned something from our short discussion. And as always, remember, science is cool.